VikLawr, the science girl.
MC squared.
The science
Velocity equals distance over time. Triple beam balance.
VikLawr, the science
Radial
girl.
acceleration equals 9.8 meters per second.
A great piece of body
Sir Isaac
unlocked.
Newton. 1 kilometer equals 10
VikLawr, the science girl.
Any floating
A falcon
object
is a
displaced with
carnivorous
heart rate of
bird.
fluid. The circumference of a donut is 4.8 centimeters.
VikLawr, the science girl.
Welcome back, Fletcher's Creek, to another episode of VikLawr, the Science Girl. I'm here today with Carmina from class 704. Say hi, Carmina.
Hi, Carmina.
And class 704 is our live studio audience. Okay, so Carmina and I are going to do several demonstrations for you all today. And we're going to start off. I know it's been a while since I did one of our VikLawr episodes, and I'll let you know what I've been up to. I'm moving into the food manufacturing industry, and I've actually come up with a new type of rice that's so light it floats. It's incredible. So we're going to show you a quick demonstration of just how light my new rice is. So Carmina, come on over. We've got my special light rice in this container, and then we have Carmina's regular rice. And what we're going to do is put this chopstick down into it. Go ahead, Carmina. And we're going to lift, and I'm going to show you just how light my rice is. Go ahead, lift. 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 No lifting. Mine's really light. What's up with that? It's incredible. Forget teaching. I'm moving into food industry. It's fantastic. So what is this all about? Do you have any ideas? Carmina, why is that happening? Why is mine lifting and yours isn't? Mine's lighter. Any thoughts? 704?
So cool.
She's right. She's right. It's lighter. Okay. We're going to talk a little bit about a scientific concept called friction. And what's happened here is these two containers of rice essentially look the same, but there's one small difference. And the difference is the light rice is absolutely identical to the regular rice, except the light rice is actually a lot more packed inside of it. So we're going to pour out, go ahead, grab your container there, Carmina, and we're going to pour out our rice. And hopefully we'll be able to see the difference between the two, and that there is actually a lot more. Now when we look at it, yeah, they look pretty much the same, but really the difference is when I poured it into the light rice, I kept tapping, and the tapping moves all the kernels of rice around so that it eliminates the little spots and the little gaps in between the particles of rice. So that when we ended up putting, go ahead, you can take your regular one here and my light one here, when we ended up pushing the chopstick inside and lifting, because the friction is so much tighter around the particles in this one, I am able to lift mine, whereas Carmina, go ahead, she can't do it because the gaps are a lot bigger around the particles of rice. There's a lot more space, making mine look a lot lighter. Okay, I'm going to stick to teaching for today. Okay, so for demonstration number 2, we're going to do actually 2, including this one over here, 3 demonstrations all about density. Now, it's my understanding that the grade 8s are starting to do a bit of work around this. And our cameraman over here, Sadak, has told us that Miss Shields? Yeah. Miss Shields did this exact same demonstration in her class today. So that's fantastic, and it's great that now the rest of the school will be able to see a similar demonstration. So what we have here are 7 different fluids, okay? And what they are written right here. So we have honey, corn syrup, dish soap, milk, water, which I've put a little bit of food coloring in just so we can see it a little better, rubbing alcohol, and then lamp oil. Now, all of these items have different properties. That's what makes them what it is. Matter has different properties to make something what it is. All of these have different densities, and what density really means is how close together the particles are packed. Right? There are microscopic, tiny little atoms in everything around us, and the closer those particles are together, the denser an item is. So we're starting with the densest over here up to the least dense. So this item here compared to the honey, the lamp oil, compared to the honey over here, the particles are further apart, even though the volume of each of them is the same, okay? So Carmina, you're going to start with the honey, and you're going to pour it into that container right over there. And we're going to lift it up so that all of you guys can see it. Super, that's good. Carmina? Excellent. So now, we're going to go with the second one, which is the corn syrup. So a slightly lighter density. So because it's less dense than the honey, each of these items should be able to sit on top of each other without mixing. Okay? And we're going to create ourselves a little 7-layer density burrito here. Okay, go for the corn syrup, Carmina. Wait till she pours it in. We're going to lift it up so you can really see the difference. Between the honey and the corn syrup, the colors are pretty close together, so it is a bit hard to see, but we'll be able to see the different layers shortly enough. That's good enough. Perfect, Carmina. Okay, next, we're going with the dish soap. Go for it. So even though you could see that the items momentarily did mix while we were pouring it in, or while Carmina was pouring it in, because it's lighter, the density is lighter, it did actually separate and move and float to the top. Okay, let's go with the milk next.
Oh my God!
Terrific, Carmina. Go now with the water next. We're just going to wait. We've got a little bit of mixed in here, and that's going to separate. Go for it. So that's our water.
Okay. Did your guys work?
Okay. Rubbing alcohol next. And terrific. And there we have our 7-layer density burrito. Okay, so demonstration number 3 is going to be using some cans of Coke, and we've got, or actually a bunch of different sodas, and we've got a tub of water here. And we're going to demonstrate some more about density. Okay, so Carmina, you've got several different cans there. Some of them are going to float, and some of them are going to sink. So, which one do you think is going to float? Pick one. We want a floater. Okay, go ahead. Put it in. Let's see what happens. No, don't open it. Don't open it. Just drop it in, the whole can. All right, do we have a floater? Yes. Absolutely. Okay, we've got another 5 to go. Let's pick another floater. Sprite, let's give it a try. What happened? It sank. Okay, let's try another. Keep putting them in. It doesn't even matter now. Let's just see what happens.
So cool!
What happened? It sank. Another one.
Oh my God!
What do we have?
Floater.
We got a floater. Another one.
Float.
Okay. Last one. Okay, so we've got 6 cans. 3 float, 3 don't. We've got Diet Pepsi floating, Diet Coke floating, and Nestea Zero floating. And our sinkers are Sprite, Vanilla Coke, and regular Pepsi. So, Carmina, what do you think is the factor that's changing the floaters from the sinkers?
Most of the diets are floating.
Absolutely.
And the ones that have like the most calories are something.
Excellent. So, interesting enough, yes, the ones that have the most calories are the ones that are sinking. I would love to say that calories don't weigh anything. In my head, they kind of do. But the fact of the matter is they don't really weigh anything. Something else weighs something, though. What's the difference between something that's light and something that's regular in this case? In the case of the drinks, what's the factor that makes it light? What are they taking out? What are they taking out? Yep. Absolutely. They're taking out the sugar. So our light versions have no sugar. They have a sugar substitute. So something like Splenda, or a lot of them have, I'm not even sure if aspartame, I know that that's a product. Mr. Baird, do you know, is that a sugar substitute as well? Yeah. That have it, whereas the other ones don't. So let's see, for instance, the Coke Vanilla has 42 grams of sugar. Okay, we've got some sugar packets here. Carmina, I want you to pick up how many packets of sugar you think 42 grams is. Go ahead. Three? Okay, 3 packets. Hold out your hands, Carmina, and get ready. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18.
Oh my God.
18 packets of sugar is how much sugar is in that regular Coke. So that's what's missing, and that's what, in this case, is making the can sink. So again, we're talking about density. The sugar is dissolved inside of the sugar is dissolved inside of the water and the different products that are go into the Coke, and it weighs it down. So more particles makes it heavier, it goes down to the bottom. Whereas those diet versions that don't have the sugar are lighter and stay rising to the top. All right, Fletchers, I'd like you to thank you all for joining us for VikLawr the Science Girl. I'd like to thank Carmina, my assistant, and 704, Mr. Baird, for joining us as our live studio audience.
VikLawr the Science Girl.
MC squared. Velocity equals distance over time. Triple beam balance.
VikLawr the Science
Rate of
Girl.
acceleration equals 9.8 meters per second.
A creep is a body
Sir
of
Isaac
water.
Newton. 1 kilometer equals 10
VikLawr the Science Girl.
Any floating
A pumpkin
object
is a
displaces
carnivorous
the
bird.
The circumference of a whole is 4.8 centimeters.
VikLawr the Science Girl.